Good evening, everyone. Uh, my name is Akhilesh Goyal, and today we will start internal combustion engines. Uh, Earlier, we have talked about steam power cycle in detail, and from today, we will take three internal combustion engine assignments. So, let's start. I think we have three, four of you, and others will join. Let's start the session. Okay. So in this session we will be talking about internal combustion engines, and we will start from very basic heat engines, the classification of heat engines, then in detail we will talk about internal combustion engine. Okay. So what is a heat engine? The first question is, what is a heat engine? So, a heat engine is something that converts the chemical energy of the fuel into the thermal energy, and then this thermal energy into the mechanical one. Okay, so heat engine is a device that converts the chemical energy of the fuel into thermal energy, and then that thermal energy into the mechanical one. Okay, that is a heat engine. And how many type of these heat engines are? These heat engines are of two types: IC engine and EC engine. IC means internal combustion engine, and the second is EC, external combustion engine. As name suggests, uh, in internal combustion engine, the combustion of fuel takes place in the engine itself. But in the case of external combustion engine, the combustion of fuel takes place outside the engine, and then the either the product of this combustion are used for running the engine, or this product of combustion used to raise the temperature or pressure of a working fluid, and then that working fluid flows through the external combustion engine. Okay, and again these IC engine and external combustion engine are also divided into two categories, that is rotary engine and reciprocating combustion engines. Okay, so again, as name suggests, in rotary engines there is no reciprocating motion, only rotary motion is there throughout the engine cycle. But in the case of reciprocating engine, a piston is there that moves in reciprocating motion, and this reciprocating motion is converted into the rotary motion, and uh, then supplied to the then received as a shaft one. Okay, and again these rotary and reciprocating engines are also classified according to the fuel use, or the cycle they work on. Like in the case of IC or internal combustion engine, these rotary engines can be divided into two parts, that is Wankel engine and open cycle gas turbine. So open cycle gas turbine we will be talking in next few chapters. And in the case of reciprocating engine, it is a gasoline engine that is also called as petrol engine. Okay, and the second is diesel engine. So we will be mostly talking about these reciprocating engines in this and next couple of chapters. And in the case of external combustion engine, also there are, in the case of reciprocating engine, steam engine and Stirling engine, and for rotary steam turbine we talked about in the last few chapters. And the closed cycle gas turbine is also a type of rotary external combustion engine. So the main advantage of external combustion engine is any type of fuel can be used to generate the combustion products, the hot gases, or to raise the temperature and pressure of a working fluid. But in the case of internal combustion engine, a specific kind of fuel only can be used in the engine, as the combustion of fuel takes place in the engine itself. Okay, so this is the limitation and advantage of IC engine and EC engine respectively. Okay, so now we will be talking about internal combustion engine. So what are the main components of the internal combustion engine? So the main if we see the main components here, so this is a very basic diagram of a internal combustion engine. So it consists of inlet manifold and exhaust manifold. From inlet, air or air fuel mixture goes inside the cylinder, and through the exhaust manifold the combustion product or combustion gases comes out from the cylinder. Okay, and at the inlet manifold there is an inlet valve that opens and closes according to the cycle, and at exhaust manifold there is an exhaust valve that also closes and opens uh, following the particular cycle. Okay, and there is the engine, this cylinder block. This is a big part of the main covering that covers the uh, mainly the whole engine, and this is the sump here at the bottom, and this is used to store the lubricant that we call as engine oil. Okay, and this is the crankcase. uh, Here inside this crankcase, this is the crankshaft here, and this crank that connects the crankshaft and the connecting rod through the crank pin. Okay, and here is the cylinder. Inside the cylinder here is a piston that moves inside the cylinder and do the reciprocating motion. This piston is connected to the connecting rod through a gudgeon pin. Okay, so these are the main components. So what, as inside the cylinder this piston moves upwards and downwards motion. This motion connected to the connecting rod through a gudgeon pin is transferred to the crankshaft through the crank, and this as this motion continues, this whole arrangement convert this reciprocating motion of the piston into the rotary motion of the crankshaft. Okay, and how a engine works can be seen in the right picture. So this is the this image shows the how a four-stroke engine works. So as you can see, initially the air comes inside the cylinder, then it is being compressed, then it burns, the gases burns, and the gases expand and piston goes downwards, and then piston goes again upwards, and the exhaust valve opens, and the combustion products goes out of the cylinder. Okay, so in the next slide we will discuss about these strokes, the each of the four strokes and two strokes in the in four stroke and two stroke engines. Okay, so and what is the in this slide we will talk about the nomenclature of IC engine. Okay, so here as you saw in the last picture, uh, there is a cylinder, piston, and this piston is connected to the connecting rod, and this piston moves inside the cylinder. So what are the uh, what are the other parameters or other nomenclatures that we should know before we discuss about the IC engine? So here you can see this whole rectangular part is the cylinder. Inside the cylinder this is the piston. Okay, this piston moves to the upward direction and to the downward direction. And the top position of this piston is called as top dead center, that is TDC. This piston doesn't go above this uh, top dead center, and the lower limit of this piston movement is bottom dead center. Below the bottom dead center it doesn't go. So a piston moves between the bottom dead center and top dead center only, and the distance between this bottom dead center and top dead center is called as stroke, that we write as L, and the diameter of this cylinder is called as bore, that we write as diameter D. Okay. uh, yes, there is this volume that remains there, but the piston doesn't go into that volume. So this small volume is called as clearance volume. Okay. And yeah, so here you can see two things. The one thing is clearance volume, VC, and the second thing is the volume that piston covers during each of its stroke. So what is that volume? That volume is from bottom dead center to top dead center. So what is the volume between bottom dead center and top dead center? That is the volume of this cylinder between this cylinder between these two positions. So this is the volume. So what is this volume? This volume is pi by 4 into d square. This is the area of the piston, and into the length. What is the length it covers is the stroke length L. Okay. So this pi by 4 d square into L is the volume that this piston covers in each stroke. So this volume is called as swept volume, and we write it as a Vs. Okay. So this is the main and basic nomenclature. And one more thing here is the compression ratio. So what happens is during the compression stroke, when the piston is at the bottom dead center and the whole cylinder is filled with the air or air fuel mixture for CI and SI engine respectively, during the compression stroke, piston goes from bottom dead center to top dead center. So the initial volume of the sorry yeah, so the initial volume uh, during the compression stroke is the total volume, that is clearance volume VC plus swept volume VS. But at the end of compression stroke, the volume remains is only the clearance volume. So final volume is only the clearance volume. Okay. So the compression ratio is defined as the ratio of the initial volume to the final volume. Okay. So that is defined as the total volume VT, that is the sum of uh, com- uh, clearance volume and swept volume divided by final volume, that is VC, clearance volume. Okay. So this is defined as the in these terms, and that can be written as 1 plus Vs by Vc. Okay. So the compression ratio is a very important parameter in the case of internal combustion engine. Okay. So let's move to the next slide where we will see like how the four stroke engine works and what are the parameters. Okay. So this is the uh, these four images shows the four strokes of a internal combustion gasoline engine. So what is a gasoline engine? That is a SI engine, spark ignition engine. So these gasoline engine can be also written as a petrol engine or SI engine. Here what SI means is spark ignition engine. Okay. So here we are talking about internal combustion engine, and we saw that internal combustion engines are based on the strokes taken by a complete cycle. They can be divided into two categories: four stroke engines and two stroke engines. So in four stroke engines, a cycle completes in the four strokes of the piston, and the stroke of a piston can be seen as either upward movement or downward movement. So in the case of four stroke engine, a cycle completes in the four strokes of the cylinder, four strokes of the piston inside the cylinder. But in the case of two stroke engine, a cycle completes in the two strokes of the piston inside the cylinder. Okay, so first we are taking here the four stroke engine, and these four stroke engines again can be divided into two type of engines, that is IC engine, that is SI engine, spark ignition, and CI engine, compression ignition engine. Okay, so in the case of SI engines, spark ignition engines, so very first we see the like which are the four strokes a engine goes through, and then we will see the difference between SI engine and CI engine. So here in the case of SI engine, so the first stroke is when the piston goes to the downward direction. When the piston goes to the downward direction, a vacuum creates inside the cylinder, and as this vacuum creates, the inlet valve opens. Because of this inlet valve opens, the air in the case of SI engine, uh, air plus fuel mixture in the case of SI engine, and air in the case of CI engine comes inside, and as the piston reaches to the bottom dead center, this inlet valve closes and the air remains inside the air or air fuel mixture remains inside the cylinder. Now the second stroke starts, that is a compression stroke, and this piston start moving upward direction. And as the both valves are closed and air or air fuel mixture is inside the cylinder, as the piston moves upwards, this air gets compressed, and when this cylinder reaches at the top position or top dead center, when the volume of air or air fuel mixture is only the clearance volume, equal to the clearance volume, a spark is generated in the case of spark ignition engine, or the fuel is injected in the case of compression ignition engine. Okay, as the fuel is injected or spark is created there, the fuel inside this clearance volume starts burning, and due to this burning, the combustion products or hot gases start expanding. Due to this, this piston gets the power, and piston starts moving downward direction, and as the gases keep expanding, the piston keeps going downwards. This is called as power stroke. And as the piston reaches the bottom dead center and the gases completes the expansion, this piston again start moving into the upward direction, and this time the exhaust valve opens. Due to this, the hot combustion gases that have been already expanded starts moving out from the exhaust manifold, and as the piston moves into the upward direction, all the combustion products goes out of this exhaust manifold. So this is how a four stroke engine works, and these four strokes are intake strokes, the compression stroke, the power stroke, and exhaust stroke. Now what is the difference between SI engine or CI engine? So as name suggests, in the case of spark ignition engines, the burning of fuel starts with a spark. But in the case of compression ignition engine, the burning of fuel is due to the, or in other terms, we can say, in the case of spark ignition engine, the air and air plus fuel mixture is already there, and it is in the compressed situation. As soon as we put a spark into that hot compressed air fuel mixture, it starts burning, and we complete the cycle. But in the case of compressed ignition engine, only the air is there in the cylinder, and at the end of compression stroke, there is this compressed air at very high temperature, and as soon as the fuel is injected through the fuel injector inside the cylinder, it starts burning and the cycle is completed. So both engine are different, as the intake for the both engine is different. For SI engine it is air plus fuel mixture, for CI engine it is only air. And the second thing is, in SI engine the burning is initiated through a spark, but in CI engine burning is burning is due to self ignition because of the high temperature of compressed air and fuel injected at the end of compression stroke. So that is the basic and main difference in the four stroke SI engine and CI engine. Okay, so here you can see, for the CI engine there is a fuel injector here, not a spark plug, and at the end of compression stroke fuel is injected through this fuel injector, and in the case of spark ignition engine, a spark is generated at the end of compression stroke. Okay, so these are the like basic difference between SI engine and CI engine. Okay, and now how a two stroke engine works, that we will see in the next slide. So in the case of four stroke engines, a complete thermodynamic cycle was there in the four strokes. But in the case of two stroke IC engine, a thermodynamic cycle is completed in only two strokes of the piston movement. Okay, so here that can be seen. So these two figures shows the two strokes of the two stroke engine. So in the first stroke, when the piston moves into the upward direction, so this time as this piston is moving into the upward direction, this exhaust port is closed, but this intake port opens. As this intake port opens and piston moves into the upward direction, the air or air gas or air fuel mixture is sucked into the engine, and as soon as the piston reaches the top position and combustion started, this piston starts moving into the downward direction, and as the piston moves into the downward direction, at the end of this stroke, the downward stroke, the exhaust port opens and this combustion gases starts to moving out, and also this transfer port you can see at the right side, it also opens. So when this piston goes into the downward direction, this green gases or air or fuel mixture that comes inside this engine block, this start moving into the upward direction, or upward direction means into the cylinder. So we can see in this position, uh, the exhaust port is open, as well as transfer port is also open. So through the exhaust port, these burned gases are going out, as well as the same time these intact air or air fuel mixture is also coming into the cylinder. So here we can see, because these two operations are taking place at the same time, this coming of fuel air mixture into the cylinder helps in pushing these exhaust gases out from the exhaust port. So this phenomena of air fuel mixture of pushing these exhaust gases from the exhaust port out is known as scavenging. Okay, so scavenging happens in two-stroke engines. As this exhaust port and transfer port are open at the same time, this helps in pushing those exhaust gases out from this uh, cylinder. Okay, so this is how a basic two-stroke engine works. So this can be seen in this small animation. As this piston goes upwards, these intact or air fuel mixture comes in, and as the piston goes down, this transfer port opens, and these gases go into the cylinder. And as these gases go into the cylinder, these gases push the combustion products out of the cylinder through this port. Okay, so this is how in only two strokes this thermodynamic cycle is completed in two-stroke engines. Okay, so these are the basic thing. And the main difference in the two-stroke and four-stroke engines can be seen as, in the four-stroke engine, the thermodynamic cycle is completed in four-stroke or two revolution of crankshaft. But in the case of two-stroke IC engines, this thermodynamic cycle is completed in two strokes or uh, one revolution of crankshaft. And also as or and also in the case of four-stroke engine, there are valves, but in the case of two-stroke engine, there are ports, not valves. Also, as for uh, rotation or each rotation of crankshaft, we are getting one power stroke in two-stroke engines. These engines are less heavy than the four-stroke engines, but also the exhaust and intake take place at the same time. There's some losses also, so the efficiency of two-stroke engine is less compared to four-stroke engines. And one more difference in these engines is, as we are getting one power stroke per rotation of the crankshaft in two-stroke engine, these engines need more cooling than the four-stroke engines. Okay, so these are some basic differences you have already studied in those videos by Professor Niranjan. So this is the like this was the basic recap of all those concepts you have already studied. And some of the performance parameters of the engine are the some efficiencies. These are indicated thermal efficiency or brake thermal efficiency or mechanical efficiency. So the definition of these efficiencies are in this slide. So as we can see here, the total energy of the fuel uh, is basically the calorific value of the fuel into the amount of the fuel that is being used per cycle. Okay, that can be said as the energy of the fuel. But this the whole energy of the fuel is not given to the piston of the engine. Okay, so a major part of this energy of the fuel is lost in the exhaust, coolant or radiation, and the small part of this energy from the fuel is only given to the piston, and this energy that is given to the piston is called as indicated power. Okay, and this energy or power that is given to the piston, it doesn't, this whole energy doesn't convert into the output output power, or this we cannot get this full indicated power at the end, but the a small part, or we can say a significant part of this indicated power is lost into the friction. Okay, and considering these loss into the friction, the net amount of power we received at the output shaft is the brake power. Okay, so we can see here the total energy of the fuel, the major part is lost, and we get the indicated power at the piston, and from this indicated power at the piston we get only the brake power at the shaft, and the small part is lost in the friction. Okay, so these efficiencies are defined as like the indicated thermal efficiency is defined as the indicated power divided by the fuel energy, and the brake thermal efficiency is defined as the brake power divided by the fuel energy. But the mechanical efficiency is defined as the brake power divided by the indicated power. Okay, so because in the mechanical efficiency only we are considering the mechanical losses in the terms of friction loss. Okay, so this way these three efficiencies are defined, and also there is a relative efficiency. So these all those engines work on a thermodynamic cycle. Okay, so the this relative efficiency is defined as the actual efficiency of this engine divided by the efficiency of that standard cycle that a engine follows. Okay, this is how this relative efficiency is defined, and there is an important term there, that is the mean effective pressure. Okay, so as we know, we get a one power stroke out of four strokes in a four stroke engine, and one power stroke in the case of two stroke engine. Okay, so if we consider a mean effective pressure, so the mean effective pressure is defined in a way, like if we consider this a constant pressure that is working on a piston, and this constant pressure creates the same power or generates the same power at the end as that is being generated by the whole cycle, or we can say the whole the single power stroke, that is defined as the mean effective pressure, and this can be written in the formula form as well. So here you can see it is written as indicated power. So this mean effective pressure can be written in two terms, that indicated power or brake power. Okay, so uh, indicated mean effective pressure, in the case of indicated mean effective pressure, it is IP here, but in the case of uh, brake mean effective pressure, we will be using brake power at this position. Okay, so this was a small recap of all those things you have already studied. You can ask questions here. If you don't have a question, we will move to the assignment questions. Okay. Okay, so let's move to the assignment questions. Okay, so you asked what's K here. So K here is the number of cylinders. Okay, so four stroke in, if we talk about the four stroke engines, they are not single cylinder engines, they are multi cylinder engines, 6 cylinder, 8 cylinder, 12, even 12 cylinder engines. So here is the number, K is the number of cylinders. Okay. Okay, now let's move to the first question of the assignment. So here it is. Supercharging is the process of. So what is the supercharging? So let's assume it is a cylinder and it is the inlet manifold. From here the air is going inside the cylinder. Okay. So this air can be sucked at the natural pressure and density, or this air can be supplied at a at some pressure higher than atmospheric pressure and higher density. Okay, so to and the amount of air inside the cylinder defines the how well the fuel burns inside the cylinder, and more the fuel burns inside the cylinder, more power we can achieve. Okay, so there are some ways to supply more air into the cylinder. These ways are called as supercharging. Okay, so supercharging is basically to supply higher pressure and higher density air to the cylinder. Okay, and this high pressure and high density air can be achieved by two ways. One is sup- through superchargers, and the second is turbochargers. So both superchargers and turbochargers are basically compressors. These compress the air, increase the air pressure and density, and feed this air to the cylinder of the engine. And these are two different terms because the supercharger is connected to the crankshaft itself and consumes some power from the crankshaft itself, but the turbochargers uh, actually works these are run by the exhaust gases coming out from the exhaust of the engine. So that's why the turbochargers doesn't take any energy or power from the crankshaft, but they use the energy from the exhaust gases. So this is the basic difference between supercharger and turbochargers. So here is the question is, supercharging is the process of supplying the intake of an engine with an air at a density greater than the density of the surrounding atmosphere. Right. This is the correct answer. Second is providing forced cooling air. No, this is nothing to do with supercharging. Injecting excess fuel for raising more loads. This is also not an option. And supplying compressed air to remove combustion products fully. Okay. So in the fourth option as well, the compressed air is being supplied, but here the purpose is to remove the combustion products fully. That is uh, not the case in the supercharging. Supercharging is just supplying the higher density air at the intake of the engine. It has nothing to do with the exhaust. Okay, so this is the correct answer. Supercharging is supplying a higher density air to the intake of engine. Okay, any doubt here? No. So let's move to the next question. So here is the next question. So a four cylinder spark ignition engine is designed for compression ratio of 9, and the swept volume is given as this. For a square engine, calculate the bore diameter and clearance volume of the engine. So here you can see, here four informations are given. The one first is four stroke engine. Okay, four stroke engine, or no. So yeah, here the main information here is, yeah, so it is a four cylinder engine. The compression ratio R is 9. The swept volume Vs is 0.0025 meter cube, and it is a square engine. Okay, what a square engine means, the bore diameter B, or we write it D, is equal to the length of the cylinder L. Okay, that is the square engine. So for these things are given, and we are being asked for bore diameter D and clearance volume VC. Okay, these two things we have to calculate. Now from the formula we know here that compression ratio R is given as 1 plus Vs by Vc, and here R is given as 9, so 9 is equal to 1 plus Vs by Vc. Okay, yeah, so from here 8 is equal to Vs is given as 0.0025 of meter cube, and Vc we have to find out. Okay, this is Vc. So from here Vc is 0.0025 divided by 8. So can anybody calculate? So it is 0.0025 divided by 8. Okay, so this comes as 0.00031 3125. Okay, so here we get a Vc is equal to 0.0003125, but this value is for four cylinders. Okay, so for a single cylinder Vc is given as 0.0003125 by 4. So that can be written as this value comes as 7.81 into 10 raised power minus 5 meter cube. Okay, so this is the clearance volume of the cylinder. Okay, so here two things were asked: the clearance volume that we got, and the second is the bore diameter. Okay, so here here the swept volume Vs is given as 0.0025 meter cube, right? This is the, yeah. So here swept volume is given as 0.0025 meter cube, and this swept volume is for 4 cylinders. So for a single cylinder, the volume will be 0.0025 divided by 4. Okay, and this volume is equal to pi by 4 d square into L, right? And here, as we know, for a square engine d is equal to L, so we can write L as d, so it will be pi by 4 d cube, that is 0.0025 by 4. Further solving it, we get d cube is equal to 0.0025 divided by pi. Okay, so who is solving this? Hmm, 1 by 3. Okay, so solving this, we will get d is equal to 0.0967 meters, and that we can write as 92.67 mm. This is the bore of the cylinder. Okay, so here we get the bore of the cylinder as 92.67 mm, and the clearance volume is 7.81 into 10 raised power minus 5. Okay, let's see what are the options. So 92 and 7.81, the first option is right, the second is wrong, third is also wrong, and fourth is also wrong. Okay, so here the we get the cylinder bore as 92 mm, and the clearance volume as 7.812 into 10 raised power minus 5. Any doubt in this question? Anyone? Okay, we can move to the next question. So the next question is, in four-stroke engine, which of the following is also known as power stroke? Okay, so which one is a power stroke? In the suction stroke, air comes inside the cylinder, so this is not a power stroke. In compression stroke, the air is being compressed, so we are not getting any power, so it is also not a power stroke. In the expansion stroke, the combustion gases are being expanded and the piston is moving downwards, so we are getting some power in the expansion stroke. So in the four stroke engine, the expansion stroke is the power stroke. Okay, very basic conceptual question. Let's move to the next question. Here you can see in this image, in the case of only expansion stroke, the fuel burns and we get the power at the shaft. Okay, let's move to the next question. The next one is, the energy of expanding gas is transferred by piston to connecting rod through. Okay, so what happens in the engine is, gas expands, these put pressure on the piston, and because of this the piston moves in the downward direction, and this downward direction and the pressure is transferred to the connecting rod. So this is the piston here and this is the connecting rod, and these are connected with gudgeon pin. Okay, so here the option gudgeon pin is right. The energy of the expanding gas is transferred by the piston to connecting rod through gudgeon pin only. Okay, this is the right answer. The next question is, the ascending order of strokes in four-stroke engine. Okay, so who is telling me like what is the right sequence? Vicky or Najibul or Anurag? Who is telling me?
So second, suction, compression, expansion, exhaust.
Yes. So first suction takes place, then this air is compressed in the compression stroke, then fuel burns and we get power in this expansion stroke, and in the exhaust stroke we move these burn gases out of the cylinder. Okay, so option B is the right option. Okay, let's move to the next question. So the next question here is the mechanical efficiency increases with increase in what? Okay, so mechanical efficiency is what? Brake power divided by indicated power. Okay, that is defined as this. So here brake power and indicated power can be written as brake power plus friction power. Okay, now see the options. Mechanical energy increases with increase in, so to increase the mechanical energy we need to increase brake power. Okay, if we increase indicated power the efficiency will be reducing. If you increase friction power again efficiency will be decreasing, but if we increase the brake power the mechanical efficiency will be increasing. So here the option brake power is right, indicated power no, reduces, friction power no, reduces. Okay, any doubt? Okay, so let's move to the next question. So this next question is which of the following is not true for two stroke engine as compared to four stroke engine? Okay, so yeah, so we have to compare two stroke engine as well as four stroke engine, and we have to see like which of the four options is not true. Okay, so let's start with the lowest or option D. So complete exhaust of products of combustion, complete exhaust of products of combustion, more uniform torque on crankshaft, greater lubrication is required. Okay, so here you can see. So the last option we are starting with is complete exhaust of products of combustion. So this is the right, actually this is the right option, not considering question. It is right for two stroke engine as compared to four stroke engine, that in two stroke engine the complete exhaust of combustion products takes place. Okay, so it is the right remark for two stroke engine as compared to four stroke engine, but here it is being asked is the option that is not true, so that cannot be the answer. More uniform torque on crankshaft, yes, as two stroke engine we get a power stroke for every revolution of crankshaft, so more torque is more uniform torque is there, so this is right, but for this question the option is wrong. Greater lubrication is required, this is also right for two stroke engine, so this cannot be the answer. Less cooling is required, this is the wrong point and this is the our answer, as we are getting a power stroke in each of the rotation of crankshaft. That means as compared to the four stroke engines we need twice the cooling of the engine, cooling of the two stroke engine as compared to the four stroke engine. So the option 1 is the correct option. So less cooling is required, that is the wrong option for a two stroke engine, because for a two stroke engine more cooling is required as compared to the four stroke engine. Okay, I hope you get it. The next question here is in two stroke engine which of the following functions are performed at the same time? Okay, so in the case of two stroke engine all the four things intake, compression, expansion and exhaust takes place in the two stroke of the piston. So it is being asked like which of the two strokes, which of the two functions takes place at the same time in the two-stroke engine. So here is a picture of the two-stroke engine. So if we see the options, compression and exhaust, no. Compression and exhaust cannot take place at the same time. This option is wrong. Intake and expansion, this is also wrong. Intake and expansion also cannot take place at the same time. And the next is intake and exhaust, and intake and compression. Okay, so here you can see during the compression, intake also takes place as the air is coming from this port when the gas is being compressed, and also during the uh, also during the intake and exhaust. And yes, and the during the exhaust stroke, uh, the burn gases are going out from this, but the fresh air or air fuel mixture is coming from this port as well. Okay, so if you see it, actually during the compression this intake takes place, but this intake of air is not going into the cylinder, so it is not the true intake to the cylinder. But during the exhaust, this intake takes place into the cylinder. So option C is the right option. The intake and exhaust takes place at the same time in a two-stroke engine. Okay, so next is the last question. So this is the relation between indicated power, friction power and brake power is this. Yeah, this is the true option as we saw there, that if this is the indicated power and this is the brake power, and this remaining is the friction power. Okay, so indicated power is the sum of brake power and friction power. Okay, so this option is also true. Okay, yes, so these are the questions from the assignment. Any questions, anyone? And yes, Vicky, you asked whose thermal efficiency is more for CI engine or SI engine. Okay, so the thing is you are asking the efficiency for SI engine and CI engine. So in the next chapters we will be discussing it in details, but let me give you the answer here only. In the case of SI engine, the compression ratio ranges from 6 to 12, but in the case of compression ignition engine, CI engine, this compression ratio ranges from 16 to 24. Okay, so as the compression ratio of CI engines is high compared to SI engine, the thermal efficiency of CI engine is higher compared to thermal efficiency of SI engine. And why and how this thermal efficiency of CI and SI engine depend on compression ratio, we will talk about it in the next lectures. Okay, but the efficiency of CI engine is always higher than the efficiency of SI engine because the compression ratios are higher in the case of CI engines. Okay, Vicky, I hope you got the answer. Yeah, any other questions? Okay, so if you guys don't have any question, we can close this session right here, and in the next session we will be talking about the standard cycles these CI and SI engine follows, and we discuss those cycles in detail in the next few chapters. Okay, so let's close the session. See you all guys in the next session.